Okay, so good morning, everyone. In this first talk, Living on the Moon Settlements idea, we will discuss about space architecture, especially the different type of habitation models and their technical feature, from the lunar gateway to the building of the moon surface. So I want to present myself. I'm Ilaria Fiore. I'm at last year students on building architectural engineering at the Politecnico di Milano, and I'm specialized with a thesis in space architecture and space tourism. I'm also in a research program, the Andromeda program with the Deep Space Initiative, which I will present my first paper in the ISC, and I'm also a member of several associations like Moon Village Association, but also SEDS Italy, SJC, and also others. So let's start. So what is space architecture? We can resume it with this definition. Space architecture is the theory and practice of designing and building inhabited environment in outer space, but is not only in outer space, is also in extreme environment on the Earth, like the South Pole, the North Pole. So when we are approaching the space architecture, we must also interact with other fields and acquire cross-cutting skills, as the success of any project is determined by the cooperation of different professionals. And space architecture is interdisciplinary and connects diverse fields such as aerospace engineering, architecture, design, human factors design, space science, medicine, psychology, and art. It therefore combines the accuracy of technical system, humans' need for working and living the interface design for the relationship between humans and the built and natural environments. This definition is taking from the Millennium Charter, which is a milestone for space architecture, like a manifesto for several architects around the world made more 10 years ago to define what the purpose of space architecture is. So why is important space architecture? The figure of the space architect was recognized in the space sector very, very late. And work with space architect began in 1960. And one of the examples is the studio of Vladimir Kilomey that designed the Salyut 1 space station, which launched in 1971. But now, from Space Agency, the figure of the space architect is beginning more and more recognized, not like the past. And why? Because they can solve problems related to the compartmentalization of the spaces and the ergonomics of interior to make them not only efficient, but also on a more human scale. And this is basically the principle of the human-centered design approach. Okay, let's go further. So now we can talk about some different kind of projects. So space architecture is characterized mainly by two types of projects. The first one is on the lunar surface, where they will interact directly with the ground and the environmental features, which are really different from those on Earth. And the second one is on the orbital habitation model that are going to represent one of the most important milestones of the coming years. Okay, so how we are going to the moon? We will build an Artemis base camp on the surface and the gateway in lunar orbit. Their elements will allow our robots and astronauts to explore more and conduct more science than ever before. This is what NASA tells us, and now we can go into details to discover what will actually take us to the moon and how humans will interact with them. Okay, so landing on the moon. Here, we are going to look at what are the major technological players of the next few years, which are going to mark important milestones. The first one is the Orion spacecraft, the NASA spacecraft that will carry astronauts from Earth to lunar orbit and back. The Space Launch System rocket, the rocket that can send the Orion astronaut and cargo to the moon on a single mission. And upon launch, the SLS will be the most powerful rocket into the world. The third one is the Exploration Ground System, the structure on the ground necessary to support the launch and recovery of a returning astronaut. After that, we have the Lunar Gateway, the spaceship in the lunar orbit where astronauts will transfer between Orion and the London or regular Artemis mission. And this is a really, really important project, and the space architects have a main role in this project. After that, we have the human landing system built by American companies that are the final mode of transportation that will take astronauts from lunar orbit to the surface and back to orbit. The last part is the Artemis base camp to give astronauts a place to live and work on the moon, include a modern lunar cabin, a rover, and a mobile home. But about the structure on the lunar surface, Paolo Caratelli will explain better all the features. Okay. Now, a little introduction about the Orion spacecraft and also why the figure of architect is important also in this step. Now we can see the Orion spacecraft for NASA crewed Artemis 2 on the right, the Artemis 3 on the left, and on the center, the Artemis 4. And they are all in the Neil Armstrong Operation and Checkout building at NASA Kennedy Space Center in Florida. This is a photo of the 22nd of June. So it's something really new photo. Each capsule is in a different stage of production. And we can see that the capsule of Artemis 4 just arrived in February, so it's really an early stage of assembly process. Inside the Orion capsule, we will travel the 4 chosen astronauts. They will stay in the lunar orbit for a period about 10 days. And as we can see, the spaces are very small, but here we can see the spaces are really small, but the main purpose is for this mission is also to test the life support system and if they can pass to a short-term mission to a long-term mission. Now we can maybe talk about some dimension, and these have a height of 7.3 meters and a width of 5.2 meters. The Orion is composed by the EMS, the European Service Module, and the crew capsule, where the astronaut will be. But the Orion is really strictly related with the SLS rocket. And here we can see the configuration and how is really little the module of the Orion compared to the dimension of the SLS. But this is because up to reach a really long distance. So the next, and here we are. This is, as I told before, one of the most important milestones of these decades, the Lunar Gateway. The next space station will be the Lunar Gateway, and now is under development, and it will be open the moon serving as a pit stop for the future human mission to the lunar surface. And as we can see to this image, there is the cooperation of different actors. are basically the same partners that were building and operating the ISS, and they will use their experience to build up a structure that is similar, but in this case is much smaller inside. So it's also a challenge. And here we can see the two habitational modules, the HALO, the Habitational Logistic Hotspot, and HIAB, the International Habitat. About the HALO is the pressurized environment where astronauts visiting the gateway will work and will provide commands and control, as well as serve as a docking hub for the hotspot. And HALO will also support scientific investigation, distribute power, provide communication for visiting vehicles and expeditors bound for the lunar surface, and integrate the LOVE support system aboard Orion, because also the Orion module can be attached to the HALO and also to the HIAB. So the HALO can provide also system support to the life support system of the Orion. Okay, now we can talk about the HIAB. The HIAB is one of the most interesting habitational module of the Lunar Gateway. In this moment, there is on construction in Turin, in the Thales Alenia labs. And now we can see an introduction, a little design, a concept of the HIAB, because basically all the information that we have before the officially construction of the HIAB. After that, the JAXA, the Thales Alenia Space, also the Liquid System Group are on NDA. So we don't have a lot of information, but we can understand in this image how it's challenging construct modules like this one. Now here we can see an astronaut that are doing some experiment, and the space is really, really little. So this is the big challenge. Here there is a architectural image, and the architect Le Corbusier developed such a human proportion system and published in 1958, and name it the modular. For him, it was the base for the space science, sizing and furniture design. But this is really important because we can understand how also in the past there was the need to optimize the space based on the human need. With changes in gravity condition, humans have moved in different way. And this must be considered when allocating room requirements for different activities. And also different gravity conditions have different impacts on our body and also our posture. And unlike gravity, where we usually stand more or less upright, in microgravity, we're floating. So it's called neutral body position. We are more relaxed. And this is the starting point for most of our ergonomic study. And the baseline for designing a room like crew cabin, galleries area, human-machine interface, and all the other space. Now I want to show you some pictures that are really interesting. This is a study of NASA. This is NASA Human Interaction Handbook. NASA has also produced a very detailed handbook in which the human body studies in all these parts, from dimension to the possible movement of each limb, really everything. Here there are some diagrams. On the left, we can see the dimension of the human body. And on the right, we can see the posture that change in a zero gravity. And there are all aspects that we need to be considered as we will move to a short-term mission, to a long-term mission, but the size of the model will be very small. So it's also going to affect the health of astronaut. For example, in the high up, the dimension is really, really small. So if the astronaut is tall, cannot stay in a straight position. In addition, ESA with the Para-Astronaut project, as shows John McFall, the first astronaut with a disability. And this will lead to new consideration and new ways for looking the space, make it usable for the whole crew, for the future mission. Disability in space is really different from disability on the Earth because there is no gravity. But it's something that we have to start to considering also when we build habitational model and also the house on the lunar surface. Okay, now this is now we're going a little bit more in detail about the HIAB. The main interior architecture of the HIAB is the overall interior dimension, the volume and the mass that have been determined by the launch vehicle capability, as we can see here. Initially, the HIAB was to be launched by LS, but after they decided to launch it with the SpaceX Falcon Heavy, this has further constrained the HIAB to an inner dimension, so to 3.4 meters, due to reduce payload, shore dimension, and the need to accommodate the docking target for the radial docking port. Also, the use of the Falcon Heavy required that HIAB be launched in tandem with the service vehicle for the lunar orbit to accommodate both elements on Falcon Heavy. Both elements. Okay, and yes, the main challenge is provide a queue to the crew with an optimal living and a working environment for their daily needs. And the configuration of the HIAB have to provide a lot of function. Now we can see some of them: the cargo storage, the science payloads, the private crew quarter, gallery facility, hygiene facility, waste management, system boxes, internal robotics or exercise equipment, airlocks for transfer to other pressurized elements, refrigeration for food and science sample, water tank, and many others. So there are really a lot, but the space is really small. Next. Here we can see the disposition of the first design of the HIAB. Yes, the space is really small, but if you have to compare the designing a room on the Earth and designing a room like that on the space, we have also considered that we can design everything on a 36-degree and not on all the wall, and not just the wall that we can touch with our hand, also on the top. So we have more space. Okay, and here we can see that the modules is like a circle, but the space that the astronaut can use is just this in white, so it's really, really small. And this is I want to talk a little bit about the process and the space optimization. I don't know if many of you have seen The Founder, the movie about the founder of McDonald's. Basically, it was the design of the kitchen. For the design of the kitchen, it simulated the movement that all the employees will do for making the sandwich to the fries. And with this, he was going to define what was the most efficient and comfortable space, sequence, and configuration. And this is what exactly they're done now with the HIAB, because they have the basic structure. it's already built. So they are optimizing the space based on the need of the astronaut, which can be from moving a panel or changing the material of some desk or everything. And here we can see some image of Alexander Gress in 2022 with the virtual gateway for you system. And together with the team of Thales Alenia and HESA is testing the modules to see if they can optimize something. And they are doing this with also other astronauts to optimize the space. Now, just a little introduction, a few words about the life support system. For every module, we need the life support system. It's really important because when we build, when we think to build something in the space, we have also consider how we can, how to say, we cannot waste, because if we need water, we have they are, I don't know how to say it, sorry. Okay. The life support system is really important because if we are in space, we don't have to waste anything. So also the air, the water, everything, also the urine have to be have to enter in this circle to be recycled and reuse it again. This is really important. This is the ISS cabin and the life support system of the ISS. This is obviously the most studied and the most optimized, but here we can see that all the system, the subsystem, like for the water, for the air, for the oxygen and others are not closed. So the goal in the next year is also to close that system. And here is not a great image, but is the concept of also the Melissa project. This is one of the goals that we have to try to achieve about the life support system, also for the module of the Lunar Gateway and others. And here, the last step, Lunar Gateway, human landing system that will give the astronaut the opportunity to go on the lunar surface with the Artemis base camp. They will construct base on the moon, and the base will be in the South Pole. This is a really strategic position. But I don't want to go more in deep about the building on the surface, because I know that Paolo will explain it later. So I think I ended my presentation. So thank you so much.
Thank you very much, Ilaria. Paolo, are you ready to share your screen?
Yes.